Good morning, class. Today we pivot a bit and get to where we're going to develop some better tools, perhaps, for finding out the equation of a line when given certain information. We're going to start with this problem. It's called Down on the Farm. Colleen recently purchased a farm that raises chickens. She has never raised chickens before and wants to learn as much about her baby chicks as possible. In particular, she wants to know how much a baby chick weighs when it is hatched. To find out, Colleen decided to track the weight of one of the chicks that was born just before she purchased the farm. She found her new chick grew steadily at a weight of 5.2 grams, and that uh, that each it, it's steadily by about 5.2 grams each day, and she assumed it has been doing so since it hatched. 9 days after it hatched, the chick weighed 98.4 grams. So our assignment right here is to, in fact, that's kind of important information. I want to write both of those items down and just kind of keep them here. So it's growing at a rate of 5.2 grams per day, and she's going to make the assumption that that's always been the case. And she knows that on day 9, 9 days after it hatched, the chick weighed 98.4 grams. Of course, she wasn't at the farm when the chicks were hatched, so she couldn't weigh them on their hatch day. She had to weigh them later, and she's trying to figure out what they would have weighed at the hatch day. So I'm going to write this down as an ordered pair. 9 Day 9 has a weight of 98.4 grams. So our task right now is two, right? The two things that we're going to do is we are going to create well, we're going to model this situation using two different representations. One of them is a graph, and the other thing that we're going to use is an XY table. And then after we've got that model set up, we're going to assume the chicken will continue to grow at the same rate and determine the weight of the chick, or actually determine when the chick will weigh 140 grams. So how many more days, or how many days does it take for a chicken that's hatched to get to 140 grams? And I'm not sure, but no, that's not the weight that they are when they start laying eggs. If you got chickens for eggs. Okay, so let's look at our first representation, the graph. Now, one of the problems with this is these are not the nicest of numbers, and even looking at this, I'm here's day 9, and somewhere at day 9 I have to hit about 98.4. So I'm thinking it's somewhere in this area, right, somewhere in there. But then I have to go down by 5.2 grams and over back one day. So somewhere in here, and I keep doing this, realizing that I'm trying to be careful, and I know that I'm counting down like 5 of these little lines and then plus 2/10 of one, but I'm not super happy with it. Now, when I do this, I get this graph, and I have a y-intercept that's somewhere between 45 and 50, and I really don't know. I'm not confident in that number at all because I don't think this process was great. But I'm just going to say, based on that, I think I have perhaps an equation. Like right now, if I was going to model, if this is my y-intercept, 45, 46, 47, it'd be like y equals 47x plus, no, y equals 5.2x plus 47. So y equals my slope times that y-intercept. So that could be a model. Let's look at another representation. Another representation we could switch to would be a table. And in a table, I've set this up so that x is the number of days past the hatch, and y is the weight of the chick in grams. Now, we do know that on day 9, we're at 98.4 grams, so I can go ahead and write all of my days in, and then at day 9 I can go ahead and add the fact that we were at 98.4 grams. Now, because I know the slope is 5.2, if I was to move forward, I'd be adding 5.2, but I want to fill out the rest of this table, so I'm going to subtract 5.2, and when I subtract 5.2 from 98.4, I get 93.2. That's just taking away 5.2. And if I do it again, I land at the number 88. And if I do it again, I land at the number 89, I'm sorry, 82.9. This is kind of laborious, so let's speed up a bit. The very last time that I subtract the 5.2, I land at exactly 51.6 grams. So that's remarkably different from the y-intercept I got when I did this graphically. And I have a lot more confidence in this method in terms of getting me the correct y-intercept. But this still has a drawback, right? Creating this table, doing all this subtraction problems is kind of laborious. But at this point, I do think that I could confidently write the equation of this line. And that would be a good tool for moving forward. In fact, let's write this down. I'm going to say that the y-intercept is 51.6 grams. So when the chick was hatched, it weighed 51.6 grams. So that's one of the questions she wanted to answer. We've answered it. The other question that she was interested in was when will the chick weigh, I think it was 140 grams. So to answer that, what we're going to do is go ahead and write down our equation. And because we're assuming a linear model, right, we've got y equals mx plus b. At this point, we know both of our parameters. We know our slope parameter is 5.2. And we also know that our y-intercept is 51.6. So I can rewrite this putting both of those values in. Again, the big question is when will this chick weigh 140 grams? And it's important to remember what the variables represent here. X is the number of days past when the chick hatched, the chick hatched, and y is the weight in grams. So what I'm going to do is I'm just going to write 140 grams in for y. And I'm going to solve this for x by first of all taking away 51.6 from both sides, and then dividing both sides by 5.2. When I do that, I get that x is 17 days. So in 17 days, I expect the chick to weigh 140 grams. But wait, there's more. So we did this in two ways, right? We did this using a table, and we did this using a graph. I think my y-intercept from the graph was embarrassing, right? I got like 46 or something, 47. The y-intercept for the table, I believe my arithmetic was correct, was a lot better, but it's still time-consuming and kind of laborious. So let's see if there's a better way. So in fact, let me clear this screen off. And what I wanted to consider is let's go back to our original equation. I don't like this color pen. Let's grab this black. And if we go back to the fact that we're considering a linear model, we've got the y equals mx plus b. Now it turns out I know some things just looking at this equation. One of the things I know immediately is I know the rate of growth, right? I know that my slope is 5.2, and we've practiced a lot getting the slope value. I think at this point we can pretty consistently get slope from 2 points, and I think we're pretty good at reading the slope from a graph if the graph is accurate enough. The other thing that I know, it turns out, is I've got an XY data point, right? I know that when X is 9 on day 9, the chick weighs 98.4. So what I can do is I can replace the y value and I can replace the x value in this equation with this particular day. So I can write 98.4 equals 5.2 times some value x, which is 9, plus b. Now, one of the things that I notice all of a sudden is that the only thing left in this equation is my parameter b, which is great because I'm trying to figure out a simple way to figure out what that parameter b is. And I can do that now by just solving this equation. So on the right-hand side, I'm going to replace this with that product, right? I'm going to write this as this is 46.8, and over here I've got 98.4. Okay, and then plus b. And I'm going to take away 46.8 from both sides. So I've got 98.4 minus 46.8. And that gives me 51.6. Now, this number is very familiar. This number is exactly the y-intercept I got from my highly accurate table, right? And the beauty of this is now that I know this y-intercept, I can come back to my original y equals mx plus b, and I can replace both parameters. I can put in both the slope parameter, and now I can put in also the y-intercept parameter, and I can write the equation of this line. So I would rewrite this as y is equal to 5.2x plus 51.6. And the beauty of this is, right, is now all of a sudden this behaves exactly as I want it to. If I put 9 into that, for example, 9 times 5.2 and then plus 51.6, it gives me the exact 98.4. And I know that at day 17, I'm supposed to weigh 140 grams. I figured out that from the table. And yeah, if I take 5.2 and I multiply it by 17 and then add 51.6, I also get the 140 grams. So this is the equation of my line. And I got this, right, without making a table, without drawing a graph. I did it purely algebraically. Please make sure you include this in your notes. This is an important idea, and you can see that I had a point. I was given a point, and I also knew the slope. And from that information, right, I was able to find the equation of the line by first of all considering that it's a linear relationship, and then plugging in three things. I was able to plug in the value of the slope that I had. I was able to plug in, which was 5.2, and I was able to plug in the x and the y from the point that I had. And then once I did that, I just solved for parameter b. And once I knew parameter b, then I just wrote my equation, y equals mx plus b, plugging in both parameters, my slope parameter and my y-intercept parameter. Before we go off and do a bit of practice, I want to just illustrate one more example of this, and I'm just going to do A. I encourage you to do B also, and just know that you're correct. You know that you're correct if your answer to B has the correct slope, right, 0.5, and when you plug in 28, it should give you 0, so that's a nice way to do a check. So let's go ahead and look at A. So I'm going to start with the fact that it says that these are lines, so I know I can use y equals mx plus b. And I know my slope parameter is -3. And I also know that this line is going through the point where x is 15 and y is 50. So I have an x and a y value. So what I'm going to do is go ahead and replace the y, the x, and my slope parameter, and then I'm going to use that equation to figure out my y-intercept parameter. So I can write y, which is -50, equals m, which is -3, times x, which is 15, and then plus b. So I've got this -50 is equal to -3 times 15 is 40, -45 plus b. If I add 45 to both sides, I should get that -5 is where my y-intercept is. So now I know both parameters. I know my slope parameter, and I just figured out my y-intercept parameter. So now I can write the equation of this line. The line is y equals -3 times x minus 5. And just by way of a check, if I take the number 15 and plug it in for x, notice that does become -3 times 15, which is a -45. And -45 minus another 5 is -50. So yeah, when I plugged in 15, I did get -50. So this is the equation of the line that goes through this point and has this y-intercept.